Hi, my dear students. Good morning to all. This is Kritika. I am handling 10th Standard Maths. I hope you and your family members are safe at home. Before entering into the session, I just want to share the motivational quotes. When our signature changes to autograph, this marks the success. Let's start the session. Unit 8 Statistics and Probability. In today's class, we are going to discuss about statistics. First two exercise among statistics, remaining exercise and all probability. So, today we are going to see the introduction about statistics. So, statistics, it is derived from Latin word that is status, which means a political state. So, today statistics has become an integral part of everyone's life. Suppose in our family members that are having a growth, that is suppose your father income is again started from 2020, that is in the 10,000 means in 2021 if it will be increment 2000 means that is what 10,000 plus 2000 we get what 12,000. So what about 2022? That is if you have the increment, same increment means we have the 14. So if you have making a plan for our future, doing a business, marketing research or preparing economic reports. So this and all using for the statistics. Then the study of statistics is concerned with scientific method for collecting, organizing, summarizing, presenting, analyzing data and making meaningful decisions. If you use the statistics means we have to tell that what is that meaning. If you make a 1 rupee, if you add means why you add the rupee, 1 rupee, like that we want to making a meaningful decision. So in previous class, that is in 9th standard, you already seeing about a collection of data, presenting the data in tabular form, graphical form or and collecting the measures of central tendency. So here we have to going to see about the new topic, that is measures of dispersion. This is the your first statistics you have to see the class, that is measures of dispersion. First of all, I want to recall the previous class, that is measures of central tendency. It is that whole data represent the whole data, that is called measures of central tendency. So if you have one number means that represent the whole data, such a number is called measures of central tendency. Here most of the common, that is you have seen arithmetic mean, median, mode. These three method uses for the measures of central tendency. This is one note you have to study, that is data. What is meaning of data? That means the numerical representation of facts is called data. The numerical representation of facts is called data. Then observation. So each entry in the data is called an observation. What is that data? What is that observation? That is numerical means what? Number 1, 2, 3 like that. If you have means that is a number. That is entry in the data means that is in the form. If you have any number of students, 20 students, 30 students, 30 students height like that. If you entry the data means that is observation. So each entry if you want to check. Then variable, we know that variable, that is what x, y, z, a, b, c, d like that. Here we can say that the quantities which are being considered in a survey are called variables. Variables are generally denoted by xi, that means x1, x2, x3 like that we have to mention in the variable for the statistic. Then frequency. So frequency means the number of times a variable occurs in that given data is called the frequency of the variable. So frequencies are generally denoted by fi. So I is represented as 1, 2, 3 etc. up to n. So it is in the, we have to study it in the previous class. What is that? Arithmetic mean, median, mode. So mean means, arithmetic means mean, we have to calculate, that is x bar. So here we have to say that arithmetic mean or mean. We have to say mean or arithmetic mean, or otherwise you can say AM. Like that we have say in that questions of the given values is sum of all observation divided by the total number of observation. So it is denoted by x bar. So this is the formula you have studied in the 9th standard itself. Here also some of the places if you want means we have to use this formula. So arithmetic mean, that is AM, if we ask means x bar equal to sum of observation divided by total number of observation. So here methods of finding mean, so many methods are there. So here first of all we want to check, that is two method, that is in that two method we have a separated branches. What is that two method? Ungrouped data, grouped data. So in ungrouped data means we have to use the direct method, that is what? X bar equal to, here we have same in sum of all observation divided by number of observation. In formula we can say means x bar equal to summation I equal to 1 to n xi divided by n. So if you have the grouped data means what is that meaning of ungrouped data? Grouped data means nothing but if you have in the numbers, that is 1 2 3 4 etc. like that, if they given, it is in ungrouped data. We have the ending term also. For the grouped data means we have to mention in the tabular column. We have to use in the three ways, that is direct method, assumed mean method, step deviation method. Totally three method for the grouped data. So direct method means we have to use that frequency also. So x bar equal to summation I equal to 1 to n xi fi divided by summation I to 1 to, sorry, I equal to 1 to n fi. What is that, ma'am? Summation like that you have to take. This is summation. If you have say means this is one is summation. Summation means addition. So we have the numerator, we have to add that xi and fi divided by frequency. For the assumed mean data, assumed means we have to take the assumption value in between the values or whatever, we have to take that is in the assumed value, we calculate as a. So for that x bar equal to a plus summation I equal to 1 to n fi di divided by summation I equal to 1 to n fi. Here di is represented as xi minus a. If you subtract the xi minus a means we get d. Then step deviation method. So step deviation method means here one term is, another one term is there, that is c element. So x bar equal to a plus c into summation I equal to 1 to n fi di divided by summation I equal to 1 to n fi. So where di equal to xi minus a divided by c. These formulas and all they ask in the one word also, or otherwise in some sums we can use, because if they ask the method by using in the 9th class also we have to solve. Then we want to see that is measures of dispersion. It is so easy to solve this one. So see one example. Here batsman A given, batsman B is given. For the last 10 matches they scored these runs. So first match batsman A scored 25. Here B is scored 33. So totally here we have a different data is there. Batsman A and batsman B. Here we want to calculate the mean of batsman A and mean of batsman B. If you calculate the mean means what, we have a sum of all observation. So here we want to add and divided by number of observation means that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you count like this, or otherwise they told what 10 matches. So divided by 10. If you add and cancel means we get what 40. For batsman B also what we get, same 40. Here the both of mean data is same, but they differ significantly, because what first matches they scored 25. Here batsman B scored 33. Like that if you check means what, all the terms are different. So they alone differ in significantly, but mean is both datas are same. So here we have to say, means if you batsman A run is here, batsman B is run is there, here and there, first match, second match, third match, fourth match, like that they given. From that they would known what measures of dispersion. What is the dispersion? Dispersion means scatteredness. That means அதாவது என்ன சொல்லலாம், சிதறல், பிரிதல். பிரிஞ்சு இருக்கிறவங்கள நம்ம வந்து ஒன்றா சேர்க்கறது தான், தட் இஸ் வாட் scatteredness. So see the definition for dispersion. Dispersion is a measure which gives an idea about the scatteredness of the values. That means scatter means பிரிகிறது, scatteredness means what சேர்க்கிறது, பிரிதல் இல்லாமல் எல்லாத்தையுமே grouped டேட்டாவை we have to convert. So measures of variation or dispersion both are same. Here the another name is there, measures of variation or dispersion of the data provide an idea how observations spread out or scattered throughout the data. So here so many different measures of dispersions are there. That is, first one is range, mean deviation, quartile deviation, standard deviation, variance, and last coefficient of variation. In CW note, you have to write, that is, take a new page and write the date. In center, 8, statistics and probability. Then next you want to write that is formula. Here we have a one formula, that is method of finding mean is there. This all formulas you have to write, and also you have to write the note. So first of all you have to write that what is that measures of central tendency. You have to write up to that, means what if then often convenient one number that represent the whole data, such a number is called measures of central tendency. The three terms you have to write: arithmetic mean, median, mode. Then you want to write note, then you have to write arithmetic mean formula, then methods of finding mean. After that you have to mention measures of dispersion. Like that you have to write the topic and write that dispersion definition, then measures of variation or dispersion. This point also you have to write. Below that, different measures of dispersion. Like that you have to mention in the note. If you have note, that is, if you have a book also you have to write. If you don't have a book, means then see that range. So range means the difference between the largest value and smallest value is called a range. So difference means subtraction. So range R equal to L minus S. Largest value is considered as L, smallest value is considered as S. So range R equal to L minus S. If they ask coefficient of range, means if they ask, means the formula is L minus S divided by L plus S. So already I have said where L is largest value, S is smallest value. Then see the next one. Here we have a two note is there. You just recall in the book itself. That is, if the frequency of initial class is 0, then the next class will be considered for the calculation of range. So first initial value, frequency of initial value is always what? 0. So the next class will be considered the range. Then next one is the range of a set of data doesn't give the clear idea about the dispersion of the data from the measures of central tendency. For this we need a measure which depend upon the deviation from the measures of central tendency. That means what? Here dispersion of data is not clear, that so we have take the measures of central tendency from the deviation. So what is the deviation? So see the here deviation from the mean. That means for a given data with n observation, that means x1, x2, etc. up to xn, the deviation from the x bar mean are x1 minus x bar comma x2 minus x bar, it will be going on xn minus x bar. So deviation from the mean means the formula is what? X1 minus x bar, x2 minus x bar, etc. xn minus x bar. Then if you have a squares of a deviation means that means nothing but we have to square the deviation. So the square of deviation from the mean x bar of the observation x1, x2, etc. xn are x1 minus x bar the whole squared, comma x2 minus x bar the whole squared, etc. xn minus x bar the whole squared. It will be right in the symbol, that is simplifying notification, that is summation I equal to 1 to n xi minus x bar the whole squared. So here we have a note, that is we know that xi minus x bar is greater than or equal to 0 for all observation xi I equal to 1, 2, 3, etc. n. If the deviation from the mean xi minus x bar are small, then the square of the deviation will be very small. So according to the consideration, derivation of mean is, that is small means if you have the square of the deviation also what? That will be less than, that is very small. So then next definition, that is variance. So the mean of the square of the deviation from the mean is called a variance. So already we know that squares of the deviation, that is what? Here we have to say that is variance. So it is denoted by sigma squared. This one symbol is sigma. So sigma squared. So variance is formula. Here we can use this formula, or otherwise separated formula also we can use. So variance equal to mean of squares of deviation. So mean, if it is considered, means what? X bar equal to sum of all observation divided by n, that is number of observation. So here squares of deviation we have to write in the top, that is in the sum. So x1 minus x bar the whole square plus x2 minus x bar the whole square plus etc. xn minus x bar the whole square divided by n. In sum we can use this one, that is what? Sigma squared equal to summation I equal to 1 to n xi minus x bar the whole square divided by n. So again here I have repeat you, sigma squared equal to summation I equal to 1 to n xi minus x bar the whole square divided by n. This is variance. Then standard deviation is there, that is the positive square root of variance is called standard deviation. That is what? Positive square root of variance is called a standard variance. So here we have to say that is sigma, here denoted by sigma. Variance is sigma squared. So standard deviation is sigma. So here we have the sigma formula, that is nothing but the square, it will be go to the right hand side, means that is root. So sigma equal to root of summation I equal to 1 to n xi minus x bar the whole square divided by n. So here we have a calculation of standard deviation. In before that we have seen in the mean, that is finding that grouped data, ungrouped data, like that here also for standard deviation, ungrouped data, grouped data. For ungrouped data there are 4 terms is there: direct method, mean method, assumed mean method, step deviation method. From 4 method we can calculate the standard deviation. Likewise, grouped data means here we have a 3 method, that is mean method, assumed mean method, step deviation method. For the both we have a direct method is here. In for the grouped data there is no direct method. This is the difference for the standard deviation for grouped data and ungrouped data. Here we have a formula is there. Calculation of standard deviation for ungrouped data means direct method means we can use the sigma formula, root of summation xi minus x bar the whole square divided by n. Here I is represented as 1 to n. Here we have one note is there. The standard deviation and mean have same units in which the data are given. So this is so important because standard deviation and the mean have dash unit. That means same unit. So the standard deviation formula is the following process. If you used means we get the formula sigma equal to root of summation xi the whole xi square divided by n minus summation xi by n the whole squared. This is the square for the summation. Here the whole square we want to find. Likewise here we have a note is there. While computing standard deviation, arranging data in ascending order is not mandatory. That is what if you have to write that ascending order means it will be easy, or otherwise you have to write in the descending order we can use. So second one, if the data values are given directly, then to find standard deviation we can use the formula that is sigma equal to root of summation xi square divided by n minus summation xi divided by n the whole squared. If the data values are not given, this is given directly means we can use this formula. If they not given directly but the square of deviation for the mean of each observation is given means we can use this formula that is sigma equal to root of summation xi minus x bar the whole square divided by n. We can use these two formula for the standard deviation. If they given directly means we can use the first one. If they didn't give that directly and also if they given square of deviation means we can use this one. Example 8.1. Find the range and the coefficient of range of the following data: 25, 67, 48, 53, 18, 39, 44. Here we want to find the range and coefficient of range. If they ask a range means first of all we want to find the largest number and smallest number. So if you find means alone we have to use the formula because largest value in this data we have to find the largest value. Next one we want to find the smallest value. So here the largest value is, if you see, 25, 67, 48, 53, 18, 39, 44. So this one is largest value. So 67 is largest value. Which one is the smallest value? That is 18. So here we want to find largest value and smallest value for the range. Why we have to find? That is range formula is what? That is R equal to L minus S. So L is considered as largest value, S is considered as smallest value. Now we want to substitute, that is 67 minus 18. So now we want to subtract, that means 67 minus 18. So 7 minus 8, it is not possible. So borrow the term, that is 5. 17. 17 minus 8 means we get 9. So 5 minus 1 we get 4. So for 67 is the biggest one. So it will be considered as positive. So range R equal to 49. Then we want to find that is coefficient of range. Coefficient of range equal to L minus S divided by L plus S. So here we want to substitute the value, same value. So L is considered as 67 minus 18 divided by 67 plus 18. Already we know the subtraction answer is 49. Now we want to add. So 67 plus 18. So 8 plus 7, that is 15. Balance 1. We have a 85. So 49 divided by 85. So if you know the cancellation, here itself we have to cancel means we can use, or otherwise we have to straightly divide the term. So if you know means we have to divide means we get the value, that is 0.576. That is, you have to use the calculator, but in the exam hall we didn't use the calculator. For that I have do that formula. So here we have the division, that is divided by 85. 49 is not possible, so I have used the decimal and 0 and solved by the 85th table. So it will be going on. Here I have written 0.576 means it is in the accurate value, but it will be going on. If you have after 5, 6, 7 means we have considered that one number we have to add here. So like that here we have added. So 0.57 also correct alone. After decimal we want to find two numbers, so up to that if you write a 0.57 also correct alone. Example 8.2, find the range of the following distribution. Here we have a grouped data, that is age in years, a number of students. So that is first one is 16 to 18, that is 0, 18 to 24, 20 to 22, 6, 22 to 24, 8, 24 to 26, 2, 26 to 28, 2. Here we want to find the range. So range formula is, that is L minus S. So here we want to find the largest one and smallest value. How to find means we have to take the age. Don't take the number of students, because here we have a counter numbers. So here you didn't say, ma'am, the 8 is the largest one. 0 is considered as smallest value. So this is not correct one. We have to see in the distribution alone, that is in the age in years. So here the highest value is, that is the last one is highest value. So largest value equal to 28. Which one is considered as smallest value for the grouped data means, that is here we have to consider 18 alone. Don't consider the 16, because 18th group alone we have to take that value, because for the grouped data the second one alone it will be considered as the lesser one. Always this is greatest one, this is only lesser one, like that we want to calculate. So here we have the smallest value, that is 18. For the first column, that is 18 as the smallest value. Now we want to find the range, that is range equal to 28 minus 18. So if you subtract means we get 10. So that means 10 years, because age in years. So here if you calculate the range means we get 10. Example 8.3, the range of a set of data is 13.67 and the largest value is 70.08. Find the smallest value. So first of all we want to write the given, that is here the range of a set of data, that is the range of data is given, that is 13.67. So range equal to 13.67. Then largest value is, the largest value is 70.08. So we want to find the smallest value. So largest value is considered as L, smallest value is S, range is R. We know the formula for range, that is range equal to L minus S. So here we want to substitute the value. Range is 13.67 equal to largest value is 70.08 minus S, because S we didn't know. So write that same alphabet. Here we want to, this is in the plus value, plus 70.08. It will become this sign means, that is negative. So 13.67 minus 70.08 equal to minus S. So here we want to subtract. We know that biggest one we have take the first one, then second one as the smallest least one. If it means calculate easily. So here the greatest one is 70.08 minus 13.7. So we want to subtract. So 8 minus 7 we get 1. 0 minus 6 we can't. So there's See that here we have the decimal point is there. So I have write same position for the two numbers. So now we want to borrow. Here nearby also we have a 0. So 7 alone here we have a. So this is 6. This one is considered as 9. This is considered as 10. Decimal is not a problem. You have to borrow as usual for the subtraction. So 10 minus 6, that is 4. 9 minus 3. Before that we want to write that decimal. So 9 minus 3, 6. 6 minus 1, 5. So the value is 56.41. So here which one is greater one? That is 70.08. So the sign is minus. So minus 70.08 equal to minus. Yes, both the sides we have a negative sign. That means cancel the negative sign. So the smallest value S equal to, that is 56.41. So 56.41, that is the correct answer for the smallest value. Okay students, today's session is over. Write your CW, that is neatly, because I given the so many definitions, formulas and also some examples. You have to write neatly, properly dears. Thank you.